Evening, sir.
Good afternoon, students. How are you doing today?
You're doing fine, sir. Good afternoon, sir.
Hi, students.
Hello,
Oh,
sir.
so maybe you guys not hearing me.
Sir,
Let
can
me
you hear
go
me?
again.
Hello?
Can you hear me now?
We can hear you, sir. I don't think you are hearing us.
Right. I really wasn't sorry. Good. So good afternoon to you all. Um, I'm seeing 7 of you here so far. Um, well, now 8 of us. Um,
Good evening, everyone.
how you doing, Kahim? So what I
Good
want
afternoon.
us, hey, how you doing?
I'm not too bad, sir.
Okay.
Sir Wagwan.
Boy, Andrew, if I tell you, you just say a lie, me I tell. But I'm giving thanks. Could have been worse. All right. I'm going to I'm going to go through some stuff. The semester has technically begun, and we have quite a bit to run into. No, I mean literally, it's quite a bit that we will need to go through. I have I have an area that I really want to start off with you. And I just want your undivided attention. Sorry for those who aren't here just yet. They will catch the recording, so it is that they can catch up on us. The difficulty that I'm having, students, is that both classes are um, at 5 o'clock. I don't have a 7 o'clock session where I say, boy, needs be I can make up. after the 9 o'clock hour. Because when 7 o'clock comes, I have to go because you two will have a class. Am I correct or am I correct?
You are correct, sir.
You're correct, sir.
All right, so 5 o'clock it is. All right. I want us to start at a particular spot today. I am not going to do that just yet. I'm actually going through my notes. Yeah, I'm not. Should I? No, I'm not doing that. Particularly going to be going through something here. All right, I found where I want to go. All right, no, so hear me out. It is this calculus 2, and I need to just get your input on this. This calculus 2 is, as I told you last class, is a lot on application. It's a lot on application. Now, I can take one of two strategies. I can take a new approach, or I can take the approach that I have always been using. The approach that I've been using is giving real life examples. So it is that you can understand and see the mathematics behind it, or it is that I can just go and just teach it and you try catch it. Let me know which of the approaches you want.
Teach and try catch.
Teach and try catch. I need some other views. Oh, sorry. Somebody's saying something? I'm not hearing.
I was saying the old approach.
Okay. Anybody else?
To repeat the options again.
What I can do, I know some of you said that you don't like when I do the okay,
Sir, I'm
artifacts,
sorry,
I
I
hear that.
stepped away for a little bit, so I didn't hear
Oh
what.
no, I'm just saying calculus 2 is lots of application, and in order for you to understand some of these application, like this graph that I'm presenting just now, I can either just give you the graph and say catch it, or I can give you real life examples so that you can put it into perspective and understand it better. I'm asking the class which of the approaches you want.
Sir, what you've done thus far, I've been able to. It's been good, so take your
Say
approach.
nothing. Say nothing more. All right, thank you. All right. So what we're looking at here is solving polynomials by using approximate or numerical methods. And this is really the Newton-Raphson method. This question is a must-have. It comes with anywhere nothing less than 10 marks. All right. And as I go along, I'm going to tell you what it is that I'm expecting. Nothing less than 10 marks. All right. It is a must-have. So I'm going to ask that you put on your 10 marks. Now start putting up your 10 marks. So don't worry about this ugly looking formulation. What I want you to be able to understand is what this ugly looking graph is saying with third iteration, second iteration, initial guess. This is it. I want you to work with me. We are in New Kingston. And in New Kingston, somebody says, calls 199, 991, 119, whichever one it is, and say to them, I just saw where someone in a white car got abducted. And the police post in New Kingston is asking the eyewitness to say, in what direction? And then they said that they went up Knoxwood Boulevard. Here, what is happening? Where did the abduction take place again?
Sorry, New Kingston.
In New Kingston. You have to work with me now. Took place in New Kingston. Where is my initial, so that is going to be my initial guess because it took place in New Kingston. All right. Now, the New Kingston Post will send out an alert. So therefore, what they're going to be doing is sending to Matilda's corner because if it just happened, then can't reach Ligoni already. So what they will do, they will send out something from Ligoni, and Ligoni will be coming down to New Kingston. They will send somebody from Half a Tree will be coming up to New Kingston. They will send somebody from Crossroads. So what it is that they're trying to do, they're trying to converge into that person who has abducted this individual, right? Do you think they will call Spanish Town and tell Spanish Town to get on the chase?
No, sir, because of the distance away.
Because of the distance away. Very good. Because of the distance away. So by the time Spanish Town gets into Kingston, the person will reach Harborview. All right. So they're going to be doing all of that and try to converge. All right. Now, everybody understand that little scenario right there, so?
Yes,
Yes,
sir.
sir.
Good job. Watch me here now. This is my initial guess. That is my initial guess. And my initial guess, I could call it my first iteration. So that's my first iteration. Sir, what is the first iteration? You know, I am guessing that the person turned up on the road there. Oh, Jesus. Trafalgar Road. I'm guessing that the person turned up Trafalgar Road. The person may not turn up for Trafalgar Road. The person may turn down going towards Devon House instead of going towards the Canadian High Commission, right? So my initial guess, based on what it is that I'm doing, can be right or can be wrong. Now, if I am wrong, whoever is in the area can say, yeah, man, I'm seeing X, Y, Z, and it is happening. So your initial guess can be right, and your initial guess can be wrong. If your initial guess is wrong, it means that you're driving until you all reach Papine and you're not finding this car. It means that you would have lost the battle, right? If your initial guess is on spot, for sure the person not going to go any further than maybe somewhere on Lady Musgrave, whatever the situation. Can't reach as far as Ligoni because Ligoni is coming down. So this is my initial guess. My f of x1 is my initial guess, right? Look at what I'm doing. Watch me. Look at the screen, please, and thanks. That's my initial guess. I am drawing pretty much a tangent to this initial guess. So you see this dotted line here? This is a tangent. A tangent touches a circle exactly at one point. It's circle or curve, same difference. It touches the curve exactly at one point. Not 2 or 3, it barely touches the circle at the curve at one dege point. Look at the point it touches the circle at, the curve at. This x1, see there? X1 touches the curve exactly at x1. What I'm going to be doing is drawing a tangent, to that point. All right. I can also draw my vertical line all the way up to the point where it touches a curve, and then I'm drawing my tangent. Have we been introduced to anything with tangent? What do we do when we're calculating a tangent? Let me see if you guys remember anything. When we're calculating a tangent, what are we technically doing? Finding talk to me. We did this. Anybody hearing me?
Yes,
Yes,
sir.
sir. We're
Yeah,
here.
man, so talk
So
to
along
me.
that one of this, so I'm gonna just go with a guess and say derivative.
Very good. So you're finding the derivative. All right. So remember when we were doing the implicit differentiation, I said calculate the tangent. What did we have to find, class?
The derivative.
Yeah, man, dy by dx.
Yes, sir.
So, good. So in drawing this tangent, pictorially, I'm drawing a tangent. But when I'm doing my calculations, I must find the derivative. Now, watch this pictorially. This here is going all the way down until it touches the x-axis. Wherever it touches the x-axis, look at what is happening. Wherever it touches the x-axis, look at what is happening. I'm drawing, I'm interpolating here. I'm drawing a line all the way up until it touches the curve. So this, where it touches a curve, is going to give me my second iteration. Let me go again. So I'm doing an initial guess. I'm guessing where this person is going, because the person said, you know, they go up to Knoxwood Boulevard, and I saw where they put on the right indicator and the car wheel, they turn right. So it looked like they might go turn right. Or the person may say, and they went right on Trafalgar Road. So you're having that initial guess. So I'm drawing a tangent pictorially. I'm drawing a tangent calculations. I'm going to calculate dy by dx. And I'm going to, my pictorial representation is going to be that tangent touching the x-axis. Where it touches the x-axis, in order for me to find my second iteration, I am going to carry it all the way up vertically, all the way up until it touches the curve again. That now is going to be my second iteration. Sir, it says after first iteration. After first iteration is really the second iteration. See here, x2. So this is going to be my x2 value. All right. Now, again, I am going to be drawing a tangent from this point until it cuts the x-axis again, pictorially. When I'm doing this stuff, see it right here, so anybody can pick up this f dash. Can you see that f dash?
Yes, sir. We can see the
Good.
F dash. It might look faint, but we can see it.
Yeah, man, it's kind of faintish. I'm going to see if I can get a better pick up this. So f dash, it means I'm finding the derivative. On a calculations basis, I'm finding the derivative. So when I go here and it touches the x-axis here, again, I am going to go vertically up until it touches the curve one more time. And what it is that I'm doing, I'm repeating the process over and over and over until I'm able to find this person. Because guess what? This person I must find. And I'm not going to say that this person is a dignitary, because anybody get abducted, dignitary, homeless, whatever, is important. Watch me right here. So this is my third iteration. My third iteration. And my third iteration, I'm right here. What I'm going to be doing next, I'm going to be drawing a tangent to the curve. Whenever I draw a tangent to the curve, it means that I'm going to be finding dy by dx. I'm differentiating. Sir, that don't make no sense. Thank you for asking. Let me go back here. I'm going to come back to x3. When I draw that tangent to the curve, you recognize that what it is that I have formed here is a, tell me what shape is this?
Triangle.
It's a triangle. So what it is that I'm doing is finding the tangent to the curve at this point here on the triangle. I'm going to be using y2 minus y1 over x2 minus x1. The rate of change of y with respect to the rate of change of x. I'm calculating the difference of y to the difference of x. Is that dy by dx? Somebody say yes.
Yes, sir.
Yes.
Yes, sir.
It is. So even pictorially, you can see that I'm finding dy by dx because I'm calculating the rate of change, the change in my y-axis divided by the change in my x-axis. That is when you give me that rate, that tangent. All right. So going back to my x3 again, where it cuts the graph right down here at x3, I'm going to be going all the way up vertically. It has to be vertical. And then I'm going to be drawing a tangent to the curve again. When I draw a tangent to the curve right here, again, when I'm drawing a tangent is dy by dx. Tangent is finding the rate of change of one something with respect to the other something. So I'm finding the rate of change of y with respect to x. I'm finding dy by dx. But sir, it says f dash of x. Different representation. F dash of x, dy by dx, it all means the same. All right? Then when I catch right here, so now, all I'm going to do is do the same thing again. This is going to be the third iteration, which is really my x4. I'm going to go all the way up, blow out x4, yeah, man. And then we're going to go all the way up. You're going to draw a tangent to the curve. And then guess what? When you draw the tangent to the curve, you recognize that you are going to be cutting this x-axis. You're cutting this x-axis. Whenever you cut the x-axis, given a function f of x or y equals something with respect to x, my dependent and independent variable, it suggests to me once I cut that x-axis, I am going to be finding my exact value, the solution to my equation. I'm going to be finding the solution to my equation. Once I cross over this x-axis, it means that my exact value is right here. So you see what it is that I'm doing? I'm doing several iterations until I get to my actual answer. If my initial guess is not supposed to be up here, so it's like too far, it's supposed to be down here, not a problem. If it's supposed to be up here, so, but I started down here, so it's not a problem. It will adjust itself. I'm going to press pause. Anybody understand what I just said a while ago?
Yes, sir. When you cut the x-axis, you find the value that you've been searching for. Really.
I'm finding that value that I'm searching for. Very good. So what is going to happen is this person is going to now behave erratic, because in when hear the police come, he might go on hold a return, a reverse, and then they're going to say, but why is that person reversing? No, man, in kind of suspicious. It's just like I'm on a walk with something illegal. I don't want to call it because we recorded, but him walking with something illegal. Could be something that he's smoking. Yeah, a contraband. That's the word that I'm looking for. When the man see the police, oftentimes what normally happens?
You start getting nervous and you start moving.
Start getting nervous. And the police are trained to look at body language. And then know when the man get nervous, he say, come here, man. Take off your bag off your back. Whether or not it's an illegal search or a legal search, oftentimes this is how the police operate, and oftentimes this is how they find things, right? So this is all that this here is saying. Now, let me explain to you what all of what we just did a while ago, pictorially, is actually saying to us. So in numerical analysis, the Newton-Raphson method, pretty much that is named after Isaac Newton, bright boy, and Joseph Raphson, is a root finding algorithm which produces successive better approximations to the root of a real valued function. Now, it uses the idea that a continuous and differentiable function can be approximated by a straight line tangent to it. Now, you notice that this function here is continuous. Talk truth.
Yes, sir.
Yes, sir.
Because it not lift up nothing at all. It's a continuous function. So if the function is discontinuous, meaning that there's a break in the function, it can't work. All right. Now I am going to go through a little summary here. Just to show you what it is that we're doing. So we're going to determine the value of the first iteration. We need to be able to know the first. I cannot just tell you, say, I feel for Chick-fil-A. I'm going to say Chick-fil-A, sir. But sir, Chick-fil-A not in Jamaica. It means that I start on a wrong premise, because if I'm hungry now and I tell you, say, it's Chick-fil-A I want, you have to go wait until somebody go foreign to go get Chick-fil-A and then to carry back. I could have died between waiting for that and then. So that is not a realistic need or want. But if you say to me, I feel for KFC, anywhere I am, chances are there's a KFC close by, and I can find a KFC nearest me so that I can go and have that KFC, right? So you must first determine the value of your iteration. And this is what the iteration is, by finding the midpoint of a given interval. If it is not stated, we can find a way, and I'll show you how to find a way to guesstimate your first iteration. All right. So the first thing you have to do is to find your first iteration. Sir, why you have to find your first iteration? See it right here, so your initial guess. This must be done first. You can't jump to right here, so without doing this. You must have your first iteration, your initial guess. The second thing now is to differentiate the given function. Sir, why? Because you are finding the tangent. So once you have the first iteration, you now are going to be interpolating all the way up to the graph. Having done that, you are now going to be able to say, yo, you know what is needed? What is now needed is that triangle, where it is that I must now find the rate of change of y with respect to x. Differentiation. That's what I need to do. So I must differentiate the function next. Then the second thing is that this ugly formula in pink, I must use. So you must know that formula. You must, there is no way you cannot know that formula. You must know that formula. And then we're going to be substituting the first iteration in order to obtain the second iteration. So guess what? You can't do the second iteration if you don't do the first. You have to do the first in order to get the second. And then you have to do the second in order to get, so it's successive. So I can't do the fifth iteration and then go back to the third iteration. No, I have to do the third, then jump to the fourth, and then come to the fifth. Now, guess what? There's something in this calculation where if I jump to the third iteration and I get a value, and I do the fourth iteration and I get a value, and I look at those two values, I can guess what the next iteration is going to be, and the one after that, and the one after that, because there's going to be no change, because it means that I would have already found my exact root. All right, let's go. So it's going to be x subscript n plus 1 is equal to x subscript n minus f of x of n over f dash of x of n. Sir, what? Sir, hold on, this one. No problem. This is going to be my first iteration. This is my first iteration. So my first guess is what I'm going to be substituting into the original function. And then I'm going to get out an answer. An answer is going to come to me when I make that substitution into my function. Then what I'm going to be doing is differentiating that function. And when I differentiate the function, I'm going to find the differential of that function at the point of my first iteration. So if the first iteration is 1.5, for argument's sake, I'm going to find f of 1.5. Then I'm going to find the derivative. And anywhere in the derivative I see x, I'm going to substitute 1.5 in order to get this. Then I'm going to calculate all of this. And the answer that I get for all of that is going to give me my x2, my second iteration. So what? Oh, you know that it's going to be x2. Thank you for asking. If my xn is my first iteration, it means that xn is going to be, n is 1, because that's my first iteration. And then 1 plus 1 give me 2. So that's going to be my x2. So that is going to give me my second iteration. All right? So note, you'll be required to make several substitutions. That is f of the first iterated value, and f dash of x of the first iterated value, f of the second iterated value, so forth and so on. Right? So you are using this formulation, which is what I put in green right here. You are using this formulation as many times as is required. As many times as is required until you get to your exact value. Sir, how are we going to know how many times to do it? Don't worry. Either the exam question will tell you by performing 2 more iterations, or it may just tell you, find it. You will find it, and I'll show you how. Because every time you reach a value, and the value that you get is exactly the same value as you got before, you don't need to do a next iteration, because it means that those 2 exact values tell you that you've reached your value, your exact point. Then the fourth thing now, the process is going to be repeated as many times as is necessary until the desired result is achieved. No, you won't find all of this in one textbook. It's because of, this is intellectual property. This is what I know you're going to need to do. And I'm condensing it to say that these are some 4 steps that you must learn in order to complete this Newton-Raphson method of approximation. All right. So now, I think it is time for us to look at an example. Let me ask you the question. Are you okay so far?
Yes, sir.
Yes, sir.
Good job. All right. Okay. I was catching up on some of the messages. Thanks, guys. Messages noted. Okay. So here goes an example. F of x is equal to x cubed minus 4x squared plus 1. Blowout, sir. How this move now, sir, from they call it now, from the abduction something to a practical question? This is it. You're going to make an initial guess, as I told you. Then you're going to work that initial guess, and you're going to work it, and then you're going to find a value that crosses the x-axis, that you're going to come and map that value now onto the curve, gives you your second iteration. Then you're going to differentiate it, the tangent, and you're going to extend the tangent all the way down to the x-axis. That is going to be your third iteration, and so forth and so on until you cross that x-axis, giving you
Not
your
able to
solution.
see the example.
Sir, your screen is frozen.
No, it's not. I just paused it because
Okay.
I was looking for this an example. All right. So the function says f of x is equal to x cubed minus 4x squared plus 1. Don't worry about it. This is how the questions will come. All right. Now, I am going to follow through on what it is that I said to you earlier. When do I find my exact value? Let me see how many of you are paying attention. When do I find my exact value? When what?
When you start to get the same value over and over.
Yeah, but something must happen
And
for that to
curve.
happen.
When the curve puts the x-axis.
Very good. When the curve crosses the x-axis. So Tariq, what you said will happen after the curve crosses the x-axis. So the curve must cross the x-axis in order for you to get the constant value for your stuff, which will tell you that, oh, I reached my endpoint. So getting the consistent values will tell you that you have reached your endpoint. You're not going to know when you reach your endpoint, until you see the consistency coming up. All right? So,
Okay.
So what is going to happen? When I cross the x value, what happens? Something happens when I cross the x value. Tell me what happens. I want you to think. You guys are calculus 2 students. Tell me now. What will happen when it crosses the x-axis? There is going to be, oh Lord and Father, this computer again. Something is going to happen. These computer don't keep charging me, honestly. Oh man. What happens when we cross the x-axis? Something particularly happens. Let me put back this graph and see how many of you will tell me what happens. Something happens when that curve. Watch a curve. Move, reach and cross the x-axis. What happens?
So at first glance, I'm thinking that y will become a negative number.
And that's why you are not ugly for any other purpose than to be in the session class, because you are correct, son. Excellent. Excellent, Jay. Excellent. Oh, and incidentally, I'm the only one supposed to run them joke within here. Jay, that's very good, Papa. So guess what, Papa? You say anything you eat for lunch today, eat it again. And don't tell me say never eat no lunch. That's excellent,
right.
though. That's excellent. So watch what Jay said a while ago. Tad said, sir, from what I can see, everything is positive, 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 positive. Watch me now. When it reach right here, say it is what?
Comes 0.
0. Very good. And then after it passes 0, what is it now?
Negative.
Negative. Very good. Very good. So you can see the transformation of something that is being positive to something that is going to negative. So once I change something like that, say something wrong. Just put it this way. If I am being a nice teacher all along, and then afterwards I said, no, man, sir, sounds so mean today, you're going to say, hold on, sir, something is not right. Because there is no consistency. Watch it. There is no more consistency, sir, in your behavior. Something, sir, you're all right? You sure you're all right? And then no, I may just pivot and say, boy, sorry guys, let me just take a 5 and then come back. Because you are now seeing a change. So you're moving from being positive to 0. That's a neutral point. And then you go to negative. All right. So thanks, Tasha, again, Papa. Watch this now. So in order for me to find and to test or to check my come on, don't be playing this now. Come on, man, just relax yourself. Oh, man. So look at what is going to happen. I am now going to be guesstimating. Jesus, peace. So you have to do them something. Yeah, man. I am going to guesstimate to see where my endpoint is. And look at what I'm doing for my guesstimation. I'm going to try f of 0. Anywhere in the function I see x, I'm substituting 0. 0 cubed minus 4 times 0 squared plus 1. 0 cubed is 0. 0 squared, of course, is 0, and 0 times -4 is 0. So that's going to have plus 1. So that's why my answer is plus 1. See that?
Yes, sir.
Yes, sir.
Good. I'm then going to try f of 1. Remember, mathematics is a study of patterns. It's a study of patterns. If you find a butterfly palm in Jamaica and go to Dubai to find a butterfly palm, and both of them are of the same family, they will have the same number of leaves and the leaf structure. It now gonna be different once it's the same thing. Math is a study of pattern. Now start at 0 and then jump to 40 and then come back down to 15. That now gonna help you. And that's why I give you the example I give you. It don't make sense you read somebody in Spanish town. Useless.
Too far.
Useless. Too far. And this is why in America, they talk about bolo, be on the lookout. So you may have somebody who is in service. They may we call it now, they may be off duty, but they recognize what is happening and they're like, oh no. My civil duty comes in play right now. So they're on the lookout. And the bolo is going to be in communities now. So everybody's on the lookout trying to find this person. And trust me, 9.9 times out of 10, they're going to find the person. Trust me. Watch me. So I am going to substitute. If I use 0 first, my next sequenced number is going to be 1. So I'm going to try 1. 1 cubed minus 4 times 1 squared plus 1. 1 cubed is 1. 1 squared is 1. 1 cubed, 1 minus 4 is minus 3. Minus 3 plus 1 is minus 2. Hold on there. You see what happened here, so?
It's a
1
negative.
and then -2. Positive and then negative down.
Yes, sir.
So what happens with my value? My value going to lie where and where? Between what and what?
Between 1 and -2.
Between what and what? Between 1 and what?
0.
Yes,
0.
man. Has to be.
Oh,
So it means
yeah,
that
yeah.
it means that my solution is going to be between this 0 and this 1. How you know, sir? Because when the function is 0, I get something positive. When the function is 1, I get something negative. So I know that my answer is going to lie between these two. Remember that concept, you know? Why, sir? Because of this. Determine the value of the first iteration by finding the midpoint of the given interval, if not stated. So it says, how do you find the midpoint of of two sets of numbers? Doing what and what? What is the midpoint between of 0 and 1?
0.5.
0.5, sir.
0.5. 0.5. Very good. 0.5. So what I'm doing, I'm adding the lower number, 0, and adding the other number, 1. So 0 plus 1. And because I'm finding the midpoint, I'm going to divide by 2. 0 plus 1 is 1. Divided by 2 is going to give me a half. So look here. So you will see that between 0 and 1, the function would have crossed the x-axis. Why? The value of the function has changed from positive 1 to negative 2. So since it has changed from positive 1 to negative 2, I am going to use my first iteration, see to x1 to be equal to 0.5. Sir, why 0.5? We couldn't use 0.6. No. What are we using, class? We are finding the
Midpoint.
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 The midpoint.
Midpoint. Don't use 0.4. Don't use 0.6. It's the midpoint that you're finding. The midpoint. All right. Now, what I want you to do, because me not gonna talk the whole class time, you know. And me know enough to differentiate. Watch this. You are going to write this down for me. So you know that this is going to be your x1, 0.5. What the class is going to do for me now in, I would say about 4 minutes, you're going to find f of 0.5 and write the answer down. Then you're going to find f dash of 0.5 and write the answer down. And I'm coming back to you in 4 minutes time. On your mark, get set, go. All right, I need to go and charge this thing in the meantime. No, this thing is not responding to me
Sir,
now.
could you repeat the instruction again?
I want you to do the first calculations for me. So you're going to find f of 0.5. You know what the function f is. So f up here, so x cubed minus f of x is x cubed minus 4x squared plus 1. You're going to be finding f of a half. So anywhere in the function you see x, you're going to put a half. Right? So it's going to be a half cube minus 4 times a half squared plus 1. Write down your answer. Then you can differentiate this function and substitute x equal a half in it again, and then write down the answer and tell me what it is. Follow?
Yes, sir.
All right, so let me try the mouse because the computer is just not responding. And it is dying. So let me try this mouse and see if it will make a little difference. Talk to me now. Did you find for me f of a half? If yes, what is f of a half?
Don't find it yet, sir.
All right, no problem. Take your time. Take your time. Take your time.
Sir.
All right, still working, no problem. While you work, I want you to listen to me, students. If you start, you know my style already. I'm not going to lead you down a path that is going to put you into danger. If you start from day one, listen to what I'm saying and follow my instructions, calculus 2 will not run away and leave you. You'll be up with it. So don't let one day pass without you doing what you're supposed to be doing, and you should be good to go. All right, I'll give you some more time. I'm going to mute.
Good evening, sir.
Well, go on, bossy.
Yeah, sir, it's not too much talk, sir. I'm joining a bit late. If you could have go back over what we have back over, cause yeah, we're not catch everything, please.
All right, no problem. When they have given me the answer to that, I'll speak about it.
Okay, sir. Thank you.
Cool. Any answer yet for f of a half?
Yeah, fine. 625.
For f of a half?
Yes, sir.
0.625. Anybody else got something else?
0.625 on there.
Like 0.125.
That me get too. Tariq, I'm wondering how you get 0.625. Check again for me, Tariq.
Yeah, I'm check again.
Sir, my calculator out of my head. 0.125.
Yes, it's correct, Papa. Very nice. All right. For those of you who got the 0.125, that's what I did. That's what I got when I did it. I would love if you calculate for me now f dash of x. What you must do first in order to calculate f dash of x.
Find the derivative.
Good job. And when you find the derivative, can you multiply the derivative of the function of f of x is?
Oh, sorry, I didn't
3,
do it yet.
there is a 3x squared minus 8x.
Good job, the boy. All right. So go ahead now and find f of all of that for me and tell me what to get.
Sir, I know I'm getting it wrong. I write down the formula wrong. So I need have a cube. I need have 4x, negative 4x cube, and it should be 4x squared, negative
4x squared. Got you.
No, that I'm correct. Get the answer.
You get the answer. All right,
Yes,
got
sir.
you. All right. I'm gonna give you 2 more minutes, guys, to find f dash of a half for me now, please. Help me out there, Kenneth. What is 1/8? Check that again, Kenneth, please.
So what was the answer?
Me not. Yeah, man. Okay.
Same thing.
Yeah. I thought you were giving me, Kenneth, f dash of x. I'm waiting for f dash of x. The 0.125 is correct for f of x. I'm waiting now for f dash of x. Hey, no, it's gonna take so long to do little something. Come on, come.
So I feel like I get a negative answer.
So tell me what it is.
Sir, is it negative 3.25?
Yes.
Okay.
Yeah, that me get, sir. That's
Yeah,
what I
man. So no, man, that no say. Hey, Andrew, sure. Yeah, man. So negative 3.25. All right. So look at what I'm doing here now. So I have gotten my f of a half to be negative, to be positive 0.125, and my f of x to be negative 3.125. Now look at what I'm doing. In order to find my second iteration, look at what Sir doing. My second iteration, as I showed you, is going to be my first iteration minus my first iteration here minus my f of x, f of a half, 0.125, divided by my f dash of a half, negative 3.25. Work this out for me, please, guys, and tell me if you get what I got, 0.5385.
Yes, sir. I got it.
Good job.
Excuse me, sir. Sorry for interrupting you.
Go right ahead.
Good evening, sir.
Good evening, sir.
I just wanted to confirm with that email that you sent me yesterday. I was wondering if you could update me on that, sir.
Yeah, we'll talk about it afterwards.
Okay.
Mm-hmm.
Yes, sir. I get the same answer. Might slow down, but I get that. Uh, 0.5385. Yeah.
Yeah, I'm not sure why, but I didn't get the same one.
All right, guys. So tell me now. What answer did you get? Did you get the 0.5385?
Yes, sir.
All
No,
right. No. Who said no?
sir, I did. I got 0.0385.
No, man. It off and try the calculation again. Let me pause and say something to you guys. You see, if you make miscalculations right here, you will lose the 10 marks. You have to be, if ever there is a question that you have to be accurate with, is this one. This one. So Kaim, you go ahead and try that one again for me, please. And then I'm gonna ask the rest of you. Now that you have your I2, value, your X2 is 0.835. That is going to be the rest
I break up.
do the Sir Ho.
Sorry, connection seems to be unstable, so hardly hearing you.
Find f of X2, f dash. Anybody? Anybody?
Say I break up a little bit. You can talk again. On my side.
All right, you hear me now?
Yes, sir, I'm hearing you.
Yes, sir.
Okay, sorry about that. So what I was saying to you is that having now calculated the X2 value, I'm asking you to go ahead and do the calculation one more time for me. But instead of using the 0.5, what value are you going to be using now?
0.583, 5385.
Good job. Start from a piece. Kahim, you are the only one supposed to double check your answer. And then quickly, and then we're going to do the calculation again. And then this time we're going to use the 0.5385. Quick and fast. Let me know. Just talk to me when you're finished, please. I'm right here. Are you guys okay? Are we good?
Yes, sir.
All right, good job.
Well, me alright, sir. How about everybody else?
Yes, sir. Remember, say, me forward late now, so me have pre-wagon.
Yes, and you are correct. So yes, Mr. Alvin, sir. So what it is that we're doing is looking at the function. We spoke about somebody being abducted in in New Kingston, and the police and the eyewitness says, yes, officer, they were in a white car and they turned right on Trafalgar Road. And the police officer is going to keep that person online just to get as much information. Then police is going to send a be on the lookout signal. So what technical will happen is that they're going to converge. So the police in Crossroads going to come up, and the police in Half Tree going to come up, and the police at Matilda's going to come down. And who to tell me if the police from Constant Spring going to come down? So they're trying to convert people who are going to block off that area and convert because they are trying to tie that person into you know, abducting, I mean capturing the person who have abducted this individual. So what is technically going to happen now is we trying to find the exact value of our iteration, and all of that scenario came from this thing here with our initial guess. This is our initial guess. So we're guessing where the person got abducted from. Then we're drawing a tangent to the point, to this curve. We're drawing a tangent to the curve, and we're extending the tangent to the curve until it reaches the x-axis. When it reaches the x-axis, we're going to do a perpendicular line from the x-axis all the way up to the curve again. It's going to give us another point. And that other point is going to, again, we're going to be using to draw a tangent to it. And the tangent comes here, crosses this axis, and where it crosses the x-axis, we're drawing a perpendicular line. Where it touches a curve, again, we're calculating a tangent to it. So every time you calculate tangents, what it is that you're doing is calculating the derivative. Every time you calculate the tangents, what it is that you're doing is calculating the derivative. If you look closely at the graph, you will see it says f dash of x1 and f dash of x2 and f dash of x3. Because what we're doing, we're calculating the derivatives. All right? So until we get to a point, we're going to do all of that until we get to a point where it says exact value. My exact value is going to be where I get my final answer. And you'll know when you get to that exact value because, as Tariq says, you're going to get the same answer over and over and over again. So once it is that you get your answer over and over, you just look and say, okay, here's the plan. These are the exact value. I know what the exact value is. And trust me, I will show you by use of calculator or other means of calculation that this method of approximation using the Newton-Raphson is really a method to solve an equation, quadratic or otherwise. It don't have to be a quadratic. I'm giving an example here that is quadratic, but it really don't have to be a quadratic, right? It's just a means of approximating the solution to a question, all right? So what we're doing is getting the function. We're getting the function. And once we have the function here is x cubed minus 4x squared plus 1. What we're doing, we were not given the first iteration. We were not given the first iteration. So we need to find it. How do we find it? By looking at the midpoint. How do we find the midpoint? We're going to be guessing. Uh-oh. Guess, sir? Come on. You're substituting 0. Sir, where you get 0 from? It's a guess. So you're substituting 0 into the function and you get your output to be 1. But in mathematics, you have to do things in sequence. So you can't move from 0 and then jump to 5. The next number that comes after 0 is 1. So you're then going to substitute 1 into the function. And when you substitute 1 in the function, you're going to end up with a -2. The mere fact that you change signs from being positive to negative, it means that you would have crossed over your answer. So what do you mean cross over? Your answer to the solution to the question, your solution to the question lies between this 0 and this 1. The answer to your question lies between that 0 and that 1. So what we're going to be doing now, Now that we know that the answer lies between 0 and 1, we're going to find the midpoint between 0 and 1. And the midpoint between 0 and 1 is going to be a half. So therefore, my x1 is going to be 0.5, which is really a half. From the formulation, x subscript n plus 1 is going to be equal to x subscript n minus f of n, f of x of n, all over f dash of x of n. It means, you notice that this xn and this xn and this xn are the same xn? Yes. Because to calculate the second iteration, because I have the first iteration is 0.5. So to calculate the second iteration, what I'm going to be doing is substituting my 0.5 into the function. So my 0.5 is going to be written right here, so. And then I'm going to substitute 0.5 into the function, the original function. And then I'm going to be differentiating that function. And when I differentiate that function, I'm going to substitute the 0.5 into the differentiated function. When I do that, it's going to give
you. Your voice, I'm not hearing your voice now. Okay, you're in now.
You don't hear me? Okay.
Yeah, you're in now.
You went too for a bit and then you came on back.
Okay, sorry about that. And then now, so what I'm doing, I'm putting my 0.5 into the function right here. And then I'm going to subtract the fraction now. And what is a fraction, sir? It's going to be my my f of 0.5 all over my f dash of 0.5. And this is what they did. They calculated 0.5, the function, see here? F of 0.5, anywhere in the function given, I see x, I'm substituting 0.5. And that 0.5, I'm going to end up with as 0.125. So I'm going to put down that answer, put it down safely, because I'm going to need something else in order to finish the first part of the question. So what I'm going to do now, I must differentiate the function. The function must be differentiated before I can do the other stuff. Okay, sir? Yeah, man. So I'm going to find f dash of x. When I differentiate the function, I'm going to get 3x squared minus 8x. When I get that 3x squared minus 8x, anywhere in the differentiated function, I see x. Again, I'm going to substitute at 0.5. And when I substitute 0.5, see right out here, so I'm going to get negative 3.25. I'm going to get negative 3.25. And then I'm going to put in all three answers now together in order to calculate now my second iteration. It's going to be my first iteration minus f of the first iteration all over f dash of the first iteration. And it's going to give me 0.5385. That value is my second iteration, my x2 value. That value is going to be my second iteration. Now, I can't do one. You know, them ask you to compare something. You can't use one something to compare something. You have to have two or more to that comparison, don't it?
Yes, sir.
Good. So it means now that you have to do at least one more. And I say at least, it means it could be one or several others. So I am not going to be using my first iteration now because I've already done that. I'm going to be using my second iteration. My second iteration is going to be my 0.535, 5385. So I'm going to do the calculation one more time. Doing the calculation one more time. But this time, instead of using 0.5, I'm going to use 0.5385. You get it?
Yes, sir.
Good job. All right. Anybody calculate the third iteration yet?
Yes, sir.
What you got for the third iteration?
Get 0.6635.
Anybody can share that with him? We get point how much?
6635.
All right. I'm happy that you gave me that answer. Because what was the first iteration?
0.5385.
No, the first iteration was
0.5.
0.5. What was the second iteration?
Second one was 5.5385.
And Tariq, what you saying the third iteration is now?
Third one we get 0.6635.
All right. Is it at 0.6? It's too big a drum.
It's because the first iteration is coming out to be 0.5 and the second iteration is coming out to be 0.5 something else. Jumping to 0.6 is too big a jump. So I'm going to ask you to double check your answer for me, please. Anybody else got the third iteration? Use the information I just gave to Tariq a while ago to be guided by it.
0.5769.
0.5
769.
769. Okay. That's not what I got.
0.5. I got 0.5591.
You got 0.5 what?
5591.
0.551. Well, that's not what I got either. All right. Let us backtrack. No. Yeah, still not what I got. All right. What was your F of 0.5385? When you substituted the second iteration into the function, into f of x, what you got?
Oh, I didn't do that part, sir. I didn't know that.
Sir, you mean for the f of x? For the f of x, right?
Yeah.
Negative 3.7736.
Sorry, who said that negative 3.77 a while ago?
Yeah.
Can you that was you or Reggie?
That was not me, sir.
Who was that?
Reggie, sir, me.
Okay, Reggie. You said negative 3.77?
Yes, sir.
I'm sure Reggie you seen something else on the calculator. Boy, don't play with me. Read what you seen on the calculator.
Hold on, sir. Let me check for you.
Sir, would it be 0.0069?
No, the
Or
man.
0.
For which one, the boy?
The f of x, and so put back the 0.5285.
Yeah, that's not what I'm getting.
Sir, is it 0.5367?
That's not what I'm getting either. But I think I know the problem, but I'm just kind of giving you guys a little exercise. I know the problem. Reggie, waiting on you, Papa. I want to correct something that you said. Raj, wait there.
Check it back, sir.
What you got? Anybody else? Damoy, what have you rechecked yours, Damoy? F of x, f of 0.5385.
Rechecking it right now, sir.
Oh, so I'm going answer.
Remember, guys, if you are careless with your calculation, your answers are going to be wrong and you're going to lose the mark for the question. So you have to be very mindful of what it is that you're doing. What keep? I'm not hearing nothing from you.
So I get 0. I get 0.547 for that. So yeah,
Mm.
0.547 I get.
What type of calculator you using, Terry? I hope it's not a phone you using.
No, and scientific calculator. Oh, my answer not right.
All right.
Recheck it.
It's off. Yeah, and for day one, I am now a little worried that I'm not hearing the all right. I think I know what the problem is, but
Sir, is
let
it
me hear the
negative 3.774? Sir?
say it again, Des Moines.
Negative 3
Des Moines?
point. Sir, can you hear me?
You man, go ahead now, Papa.
Sir, is it negative 3.774?
You left out 2 digits. You're close, but you left out. Well, I shouldn't say close, but you left out 2 digits.
So you want
Negative.
all of it?
Give.
I mean, so a
Yeah,
long
say,
number, sir.
no, but you don't see any number before the trees, Des Moines?
No, sir.
Unless my calculation is wrong. Unless my calculation is wrong.
Sir, it was the same thing. I was getting negative 3.7736 to be more precise.
But your calculation, that answer is not yet finished. I'm sure on the calculator, Raji, you're saying times 10 to something.
No, sir.
So,
It's our
yes,
long
sir.
number
I'm
of
seeing that times 10 to
Yes, sir.
negative.
That is.
So I take away 3.
Who told me now a while ago? I'm gonna charge you $1,000 because me, if Raji tell me same get negative 3.774, it must be times 10 to the negative 2. Negative
Negative
3.
3.
Yes,
sir.
has to be the
Seeing that.
negative 3. Yeah, duh. It must be
You
negative
want
3,
that,
guys.
sir?
Huh?
You want that, sir?
I mean, if you want that,
Yeah,
it's a part of the
I
answer.
was overlooking it, sir.
Yeah,
I
me
know
too.
you're overlooking. That's why I asked you to go ahead and calculate it. Hear me out. Hear me out, guys. Real talk now. You know, the difference with these plane crashes is a miscalculation in nautical miles. The aircraft overrun the runway is because the pilot did not come down at the appropriate time. He miscalculated some stuff. That is a matter of life and death. If somebody's supposed to do some radiation treatment and you decide, say, sure, 0.5 is not a difference. We're going to give them 0.5 more. You may kill the person. And if you give them 0.5 less, it means that the procedure had no effect because they never get enough radiation. You have to be precise with your calculation. Come on. So if you say 3.7, negative 3.77 times 10 to the negative 3, you can't assess the answer is negative 3.77. You have to tell me times 10 to the negative 3. And then now, when you do your conversion, from the standard form, 10 to the negative 3, you should get negative 0.003774. So that is my f of x value. Anybody got that? Negative 0.003774?
Yes, sir.
Yeah, man. Come on, guys. Hello. I'm big maths, not know, you know. Big maths. These areas are found in K2 mathematics and first year university math. And you're doing like a first year of the stuff too. Come on, man. This is big school something, man. All right. Go ahead now for me. Now that we know what the answer is, negative 0.003774. Here what I thought the problem was. Some people not knowing how many decimal places to go to. I normally use 4 decimal places or maybe 4 significant figures. I normally use like 4 decimal places or 4 significant figures. The more decimal places you use is the more accurate your results, your response is going to be. All right. So I normally use 4 decimal places or 4 significant figures. So if you look at it, 0.00, those 2 zeros in front of the decimal, behind the decimal point, sorry, well, in front and behind the decimal point. The 0, the other 2 zeros after the decimal point are insignificant. They are insignificant. So the first significant figure right there is a 3. So I normally use 4 significant figures or 4 decimal places, depending on how the answer looks. And you will have to learn that the art of doing that calculation or these calculations going forward. All right, I'm going to press pause. I want you now to calculate f dash of the 0.5385 for me and tell me what it is that you get. And then I want you to recalculate the 4th iteration for me, or the 3rd iteration, I'm sorry. I want you to tell me what the 3rd iteration is going to be now.
Where so for the sir?
Pano, you're not paying me attention to me.
Sir, I work, me still at work, sir. So.
Oh, all right then, cool. But I'm saying
I made the answer before.
yeah, man, I heard the answer with the 0.003774. What I'm saying to you now, I want you to go ahead and do the calculation for me for f dash of 0.5385 and tell me what you get for the answer. And then I want you to put all of them together now and tell me what is x3, the 3rd iteration.
So I think we did do that.
Where you get for the answer?
Negative 4.769.
No, I'm not like that one day. Try it again.
All right, sir.
Cool. How we stay, guys? I'm not hearing anything. How we stay?
Working on working.
I
Okay.
got it, sir. I got 0.5374.
That
For
means you
what?
get
For what? For F for
three,
the
30.
X3, sir.
oh for
Sorry, sorry.
X3. What you get for X3?
Yes, sir.
0.5374.
You get
Okay,
the
Raj.
same thing, sir.
Very good, Tariq and Rajay. That's a exact response. That's a exact response I'm looking for. For X3 works out to be 0.5374.
374.
Yes, ma'am. So it means that you'd have gotten the f of x value to be negative 3.4381, thereabout.
Negative
Right,
the
sir.
F dash.
Negative 4381. Repeat
Negative
that, sir.
3.4381.
Oh,
Yes,
yes,
sir.
ma'am.
When we run it off, we get 3.43 negative.
Say it again.
Negative.
You round up and get what?
Negative 3.438.
Okay, all right. I could work
Yeah.
with that. I could work with that. All right, good job. You know what I'm going to do? I'm going to show you what it is. Look at the screen right there. You will see what it is and see the calculations. Yes, you are correct. It is 0.5374. What is 0.5374 representing?
The third iteration.
Very good. The third iteration of the stuff. But what same difference. What I'm going to ask you to do for me now. Remember, I tell you, you're going to do it as many times as is necessary. Anybody remember when I read that?
Yes, sir.
Right. It's going to be done as many times as necessary. Then, sir, if we go to it one more time, yeah, man. Why do it one more time? I want you to find the fourth iteration for me, and I'm going to prove a point. So go ahead and find the fourth iteration. Those having problems, I am projecting the third iteration on screen. Those completing that, go ahead and calculate the fourth iteration for me, please. I'm giving you 5 minutes. Good job. Keep up the good work, guys. You're working well. So silent. I'm not working. I'm gonna drop asleep.
Where, sir?
So you did want to tell the answer now?
Yes,
So
I.
you're supposed to wait for the 5 minutes for them.
Tell
But
me,
sir, we got the well for me and Taxter so far, we got the same answer to be the same as the second iteration being 0.5374.
So what does that tell you, them more?
I think the second iteration is where the point is.
Not the second iteration, the third one. The third
The
iteration
third
is
one.
where, right, is where to, because you get the same 0.5374, don't you? Get 0.5374 for the fourth iteration?
Yes,
Yeah,
sir.
man. All right, very good. Anybody else see that, or you still working?
Yes, sir. I also
Yes,
agree
sir.
with Tim answer.
Yes, I. So I can tell you now. So let me ask you a question. What will be the fifth iteration?
0.5374.
The sixth iteration?
0.5374.
The 100th iteration?
0.5374.
Very good. So you're not going to move because you've already found your answer. Let me ask you though. Remember, does that answer look like it is plausible? Could the answer be greater than 1?
Could the answer be greater than 1?
No,
Yeah.
sir.
Why not?
No, because the answer must be between 0 and 1.
Boy, me I tell you, Tasha show up him ugliness tonight, you know. Big up my brethren. Very nice. Everybody see what Tash said a while ago?
Yes, sir. The answer
Yeah,
must
man.
Yes,
be
sir.
So what I'm saying, very good. So what I'm saying to you is, even when you get your answer, your results, it's supposed to make a lot of sense to you. Right? So
Oh, it
very good.
must match up to what you stated before.
Yes, I. Yes, I. So Taj, very good, Papa. Boy, Taj. Yeah, well, you know. No, man, this is very nice. Very nice. So if you look at it, you see that your first iteration is 0.5. You were off just slightly. So what I'm saying to you, when you do your calculation, you must find the person who was abducted. You must find the person that was abducted, because guess what? You are right on target. You're right on target. Matter of fact, this person not going to finish Trafalgar Road. By the time the person reach the British High Commission, you say, oh, come out of this, man. What kind of foolishness I do? Very nice. So it no matter, it don't make sense for you to do another iteration, because you're not going to get a different value other than 0.5374. So you know your solution. Your solution is going to be 0.3574. Do me a favor. Do me a favor. I want you all to substitute 0.5374 into f of x for me and tell me what you get. All of you, find f of x, substitute 0.5374, and just tell me what answer you get when you do that, please. And while you work, as per usual, there are 15 of you here, and I'm hearing just a handful of people talking to me. So majority of you may be working, but I also still need to hear you. I still need to hear you. I want to make sure that you are understanding. I want to make sure that you're understanding. Please, you have to still talk to me. Let me know what it is that you get when you do the substitution, quick and fast.
So I guess we can say the answer is very close to being 0, sir, based on.
Very good, very good, very good, Taj. And tell me now, Taj, when you get an answer close to 0, what is it saying to you? You have found the start with R. You found the root, the exact value. Yeah, man. You found the exact value. Very good, Taj. Taj, no man, big up myself, Bridget. Proud of you, man. Very good job, Taj. So when you get the answer being very close, a matter of fact, I love your response. Sir, the answer is very close to 0. What it is saying to you is, having found the root of the equation, it simply means then that you are going to have 0 when you substitute. You're going to end up with 0. So very good. The rest of you, are you there? Let me give you 2 minutes, please, and then you come back. Very good, Taj. You did very well
Yes,
tonight,
sir.
Papa.
There.
Let me get exact 0, sir.
You get 0 exactly? All right, that's
Yes, sir.
fine. Even closer, that's fine. All right, give me a half a second, please. All right, guys. So I won't give you any additional questions. Well, the class finished. I won't give you any additional questions. But just to say to you that that's the essence of the topic. The topic is pretty much finished. There's no variation. Well, there's one other variation to it. And let me tell you what the variation is. I did the harder of the 2 variations. Why, sir? What do you mean the harder of the 2 variations? The harder one was to go and guesstimate the iteration, the first iteration. The other variation is them giving you what the first iteration is. So it's one of 2 things. Either they give you the first iteration and you do the calculation, or you are going to determine the first iteration. And what I purposely did tonight was to show you the harder of the 2 methods by asking you how to go about calculating the first iteration. Right? by asking to calculate the first iteration. So having done the first iteration, the easier method is if they give you the question and say to you, approximate this using Newton-Raphson, and the first iteration is 0.5. You have less work to do. You have far less work to do. That would be maybe a 9 marker or a 10 marker. But to ask you to calculate ask you to calculate it without giving you the stuff, you get an additional 2 marks to do that. So the topic pretty much finished. So what I want you to do for me, go ahead, Papa.
Sorry, we see that question here in the exam. It'll be a 10 marks question.
It's about a 10 marker, yeah, man. If you don't believe me, now that I've told you that the topic is finished. If you don't believe me, go and find for me some past papers on calculus 2 and look for Newton-Raphson, and you should be able to tackle the question now on Newton-Raphson. You should now be able to do the question on Newton-Raphson. There's nothing more to it. The only thing that there needs to be done to this topic is to give you more questions so that you can be a little bit more familiar with it, right? I recognize that some of you were struggling to get the calculations done up, but outside of that,
sorry, say topic name.
Newton-Raphson.
Yes, sir. I have a calculator, yes, sir.
Yes, Colonel.
Whenever you work with something, sometimes it gives you a fraction.
No problem. Press F to D or S to D. Look in the middle of the calculator, you see F with an arrow to D or S with an arrow to D. So it means that you're calculating from fraction to decimal or from fraction to standard. So once you get a fraction for your answer, there is a button that says F to D. You press that button and it will convert it directly from fraction to decimal.
F to D.
Yeah. You're not seeing F to D?
As if something there says FAT and then B red B there beside it. Is a Casio class with calculator.
Is a Casio calculator? And you say F to D? What you see?
Fact B and a red B beside of it.
No. You want to take a pic and put it in the chat. Let me see that quickly. Because
my computer, the camera not working at the moment. Probably computer.
No problem. When you get a chance, send to me so I can look at it. And that brings me to maybe one of my final points is that you need to get your calculator like now, so that. All right, Papa. I see the message, Alwyn, and I believe you. You have to get your calculators from now, students, because you have to know how to use your calculator. Now, what I'll do for next class, God's willing, is to be very deliberate to show you how it is that you can use the answer and store the answer in your calculator. So when you calculate the first iteration and you get the first iteration, the calculators can store the first iteration. So when you're putting in the function into the other function, you don't have to be typing that value again because you can store it and recall it every time, right? So I'll show you how to use your calculator so that you can be familiar with it. Do not borrow somebody's calculator to do your calculus 2 exam, unless it's a calculator exactly similar to the one that you would be using in class. You're going to have problems. So what I'm going to ask you to do for me, you know how to source your past papers. Try start from day 1, or this is day 2. You're going to start looking at some questions on Newton-Raphson. I guarantee you have the information, you can go through the question. It may be a little bit difficult for you because you're only now learning the topic. But I'm going to tell you, you'll be fine. Proud of you. All right, guys, it's 7 o'clock. I know you have another class. Big up yourself. I will keep in touch with you. Carno, I'll soon shoot you a message. I'm going to take a little breeze off and then I'll send you some stuff. Here, Carno?
Yes, sir.
Big up yourself, guys. All the best.
All right, have a good one.
You too.